Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 68th question of the problem solving series and the 6th question of string data structure. The difficulty level for this question is easy and this question has been asked in Google, Amazon, Microsoft, Oracle and many other companies. So valid anagram. What is anagram? So in this case in this problem we are given two strings S and T. So we need to return whether T is an anagram of S or not. Anagram means if you can rearrange the alphabets or letters in string T to form string S. Okay, S and T are same, have same number of alphabets, the frequency of the alphabets in the same alphabets. Okay, so in this case T can be formed S from T. Okay, if we rearrange T, whatever the letters are there in T, if we rearrange it, can we form S? So you see here there is one N. How do we find out? If the number of letters are same, the frequency is same and there is no extra letters. Okay. So one thing is if the count of the elements that are present, if it is not same, what does that mean? If it is not same, then something is there which is extra. So we can't form, we can't rearrange elements, alphabets in T to form S. Okay. So the first thing is the size of S and T string should be same. Okay. So first thing that we will observe is this. Okay. Here in this case it is same 3 3 and here in this case it is same 7 7. Then we see okay. Now when we traverse there could be multiple letters, right? The string could be very big. So it may appear that anagram it is same, this is same. So we need to figure out whether the number of the frequency of the letters are same or not. Okay. So it could be that the size is same, but if this is N is say here, if it is in this case, this is N. Okay, we see the size is same, but this is not same because the count of N is 2, right? And the count of N is 1 here, but the count of A is 3 and here it is 2. So it won't, we can't do that. Okay. So what we will do, we need to see whether the count of each and every alphabet is same or not. Okay. If it is if the count of A in string T is S is 3, then the count in T also it has to be 3. Okay. So here you see the count of A is 3, count of N is 1, count of M is 1, and count of Z is 1, and count of R is 1. Same is for at T. Okay, so we will return true here. And here in this case, A is 1, R is 1, but T is T is 1 here. There is no T. Here there is C. So we will return false here because T is not an anagram of S. Okay. So now how do we solve this? Okay. So we are checking whether the frequency of the letters are same or not. So to check the frequency of the letters, we need to store the frequency of the letters where all the characters in the S, we need to store it. Okay, this is the frequency, right? So how do we check? What data structures helps us to store the frequency of all the elements that are present in it? Okay, so we know hashing. Okay, we'll use so in C++ we use map to store the frequency, or the hashing concept is used in the form of map. Okay, so what do we do here? So we will take a unordered map here. Since we are storing character and we'll have the frequency as integer and say we'll store it as MP. Okay. Now in the first thing we'll see, okay, if the size, if say it is not equal, the size of S is not equal to size of T, that means T can never be an anagram of S, right? Then directly return 0. Okay. It is false. 0 or false, same thing, right? Otherwise, else, what do? We see, we'll store the frequency of all the elements in S. So for int I equal to 0, I less than S dot size, I plus plus, and we will add whatever the elements are there, will increase the frequency, keep on increasing it. So that way, if we take this example, then the MP of A will become 3, MP of N will be 1, MP of G would be 1, MP of what is the other elements, A, N, G, M would be 1. So we have this stored in the map, okay, the frequency. Now what do? We see, okay, we'll traverse the string T for int I equal to 0, I less than T dot size, and I plus plus. Now we see, okay, if MP of Ti is greater than 0, then we will, if it is greater than 0, that means, okay, when we are traversing the elements in the T, we see it in the map, okay, the element is present, right? If it is present, then only it would be greater than 0. So if it is present, we will decrease the, because since we have seen it, so say here in this case n is present already, so we'll make the MP as n as 0. We'll decrease this value, right? Why do we decrease the value here? So that if it is come again, so here if it is come again, that means there is extra n in this, right? So in that case we will return 0. It cannot be extra, right? Finally it has to be 0, right? So if it is greater than 0, we will decrease it, right? So when we get A 3 times, so it will be decreased, 3 will become 2, 2 will become 1, and it will be 0, right? So if there is no else case here, that means when we have traversed it, we have traversed all the things. Because if there is any other extra elements in T, then it would have been written here only, na? Here only it would have, it would be returning 0. Since the number of elements are same, we have checked already. So the frequency has to be same, right? Here, if any element's frequency becomes like if any of the elements frequency is more in string T, so this condition would be false, right? If it is, so it will come into this condition and return 0. Okay. If this is also satisfied, we can say that, okay, well, this we can return 1. Okay, it is true. Okay, so yeah, the time complexity for this is order of n, the elements in any of the string SNT, and the space complexity is order of n. You are taking map. Okay, I hope this explanation is clear. The link to the question is given in the description. Please try it yourself and then come to me. Go to work section. Here is the 68th question of the problem solving series and the 6th question of string valid anagram in lead code platform. You can see this question has been asked in multiple companies. Yeah, the solution is the same that we have discussed already. So I'll directly submit this. So it has been accepted. So see you all soon in the next video where I'll explain the 69th question of the problem solving series and the 7th question of stack. Jai Jitendra.